All right, let's talk about special right triangles. What we're going to be doing right now is talking about the properties of special right triangles and then going through a couple little applications of special right triangles. Okay, so the first type that we're going to talk about is the 30, 60, 90 degree right triangle. As we recall, all of the angles of a triangle add up to 180. So this is kind of cool because we have one 90 degree angle and the other two add up to the 90, but they're nice and even, they're 30 and 60. And so when we talk about this kind of special right triangle, the hypotenuse is going to be 2 times the short leg, and the long leg is going to be the square root of 3 times the short leg. It can be kind of confusing, so let's use some letters to kind of outline this. When I set this up, I'm going to put my 90 degree angle in here, and I'm going to go ahead and make this my 60 degree angle up here, and my 30 degree angle down here. And so I'm completely set up for my 30, 60, 90 degree right triangle. Those are the 3 measures of the angles. And what I'm going to do is, because I've got this highlighted over here in green, everything is in reference to the short leg. So we're comparing everything to the short leg. So what we're going to say is, I don't know what the short leg is, but what I do know about the short leg is that its length is x. How do I know which one's the short leg? Notice, it's opposite the 30 degree angle. It's opposite the smallest angle. And so, because the hypotenuse is the longest, the longest side, it's opposite the biggest angle, the 90 degree angle, and the other one is the medium side. So the x, I don't know what it is, but it's opposite the 30 degree angle. Well, the hypotenuse is 2 times the short leg, which we know is x. So it's 2x. Okay, so the long leg, because we already have the short leg as x, is going to be square root of 3 times the short leg. And how about write that as x times the square root of 3. Okay, so it doesn't matter what x is. If we have a 30, 60, 90 degree right triangle and x happens to be 2, then I have 2 for 2 times square root of 3. Okay, so that's how we work with that. Now, one example, 30, 60, 90 right triangle. Find the lengths of the legs if the short leg is 5 in this 30, 60, 90 degree right triangle. I'm going to go ahead and put in my information. And it's telling us that the short leg is 5. So what I can do is fill these things in. 2 times 5 and 5 times the square root of 3, because they're all in reference to the short leg. So I'm going to have short leg is 5. Long leg is 5 times the square root of 3. I'm going to leave it in reduced radical form. And the hypotenuse is 10. Okay? It's that simple. This saves us tons of time. Why does it save us tons of time? I didn't use the Pythagorean theorem. Did you see that? I didn't have to use the Pythagorean theorem. This is a derivative of the Pythagorean theorem, but I don't have to use it to find what I want. It saves us tons of calculations. Okay, second type of special right triangle is coming up after this. In this example, I want you to see what you can do with this example, because there's a ladder leaning up against the house, or in this case, it's not leaning up against the house anymore, but they give you the parameters. We will talk about that tomorrow in class. Okay? The very next example is our 45, 45, 90 degree right triangle. So what we'll have in this case is we'll have our 90 degree angle up here, and we'll evenly divide the remaining 90 degrees by these 2 angles at the bottom. So we have 45, 45, 90. Well, what do we know about this? This is an isosceles triangle, and so these 2 sides are going to be exactly the same. The legs are the same length because they're opposite angles that are the same in a 90 degree right triangle. Okay? And so the hypotenuse and the leg, there's only 2 of them in this one because each leg is the same. So we're comparing to the leg, like we said before. This is our key here. So it doesn't matter what our leg is, because whatever our leg is, we're going to multiply the leg times the square root of 2. How can you remember this? 45, 45, 90 degree right triangle. There's 2 45s. So you could remember that that associates with square root of 2 in your mind. I don't know. That's how I remember it, okay? And so when we go through this, and we're talking about a tent rope, we're talking about a tent that comes out from the top of a tent pole to the ground. So it's going to look like this. Top of the tent to the ground. Okay, if we drew an extra little rope on there. And what they're saying is, if we drew this out, this would be a 45-degree angle. Okay? So, what happens here? Well, we've got a triangle that looks something like this. And here's my 90-degree angle. Here's my 10 feet. And here's a 45. Okay? So what does that mean for me? I know that the hypotenuse, which this is, the hypotenuse is square root of 2 times the leg. Well, we don't know what the leg is. That's what we're trying to find, so we're going to call that x. Now, how do I solve for x? Well, if I'm multiplying by the square root of 2, I'm going to divide by the square root of 2. Okay? So I've got 10 over the square root of 2 is equal to x. If you recall back to Algebra 1 or Algebra 2, we don't want things in this form. And so what we're going to do is we're going to multiply by square root of 2 over square root of 2. And so we'll have 10 square root of 2 over square root of 2 squared, so 2. And that's going to be equal to 10 divided by 2, which is 5 times the square root of 2. Those are the same thing. Okay? So that's 2 examples of special right triangles right here for you. We'll see you tomorrow.